Hi, my name is Aline Villavicencio, and I'm from the University of Sheffield in the UK and the Federal University of Rio Grande do Sul in Brazil. And I'm delighted to be here to tell you a little bit about my research interests in multilinguality and NLP applications, representation learning, cognitive computational models of language acquisition, processing, and loss, and multi-word expressions and idiomaticity. And today I'm going to tell you a little bit about the last one. So why do we care about identifying idiomaticity in language in NLP? So let me give you an introduction about what multi-word expressions are and why idiomaticity matters for natural language processing and machine learning. So multi-word expressions are combinations of words that must be treated as a unit at some level of linguistic processing. And they include compound nouns, verb particle constructions, light verb constructions, and idioms. So examples would be to have an open mind. And for you to have an open mind just means for you to be liberal, not that literally you have a brain that is open. Another example would be to give a French kiss. And a French kiss just means a passionate kiss. And you don't need to be French, you can be of any nationality to give a French kiss. And these expressions can be found in all languages and domains. So examples in Spanish would be es pan comido. In Portuguese would be quebrar um galho, to break a branch. So to give you an idea of why they are challenging for natural language processing technologies, here is a headline from a recent newspaper article talking about 11 shows that jumped the shark. If you don't know the meaning of this expression, it's really hard to guess. And it basically refers to a specific moment when a TV show goes downhill. And it's originally from Happy Days, from the series. And these days it doesn't have anything literally to do with either jumping or sharks. And if you translate or if you interpret this expression literally, you are going to end up giving incorrect information to your user. So for example, for machine translation, if you try to translate this expression using a standard translation tool, for example, for Portuguese, you are going to end up with a literal translation of this expression, and it doesn't make any sense in Portuguese. And if you try to simplify this text, you may end up with something like they moved over the fish, which doesn't make sense in English. And if you do information retrieval and you try searching for images, for example, of jumping the shark, you are going to get a lot of images about water skiing sports and shark tanks. And this is really nothing to do with the meaning of this expression. So they are interesting and challenging because linguistically they have a high degree of lexicalization. So you have expressions like to be as happy as a sandboy, where one of the words sandboy is only used in this expression. And they usually breach general syntactic rules of the language and they have greater inflexibility. So even though you can say by and large, you can't say by and short, and you can't say by and largest, even though these are variations of the word and an antonym of the word. So these expressions also have reduced semantic compositionalities. So some of them are more idiomatic, like trip the light fantastic, meaning to dance, even though dance doesn't have any relation with either tripping, light, or fantastic. But you also have other expressions like olive oil, which can be interpreted from its words as an oil that is made of olive. And they also have a high degree of conventionality and statistical markedness. So there is a preferred form that that the speakers of the language tend to prefer, like fish and chips instead of chips and fish, and strong tea instead of powerful tea. So the interesting thing is that they are all around. So they can be found in all languages, all domains, and it's estimated that 4 multi-word expressions are produced per minute of discourse. And they seem to be of the same order of magnitude as single words in the mental lexicon of a native speaker. They also appear as a large proportion of technical language. So a lot of the technical terms are going to be multi-word expressions like natural language processing, artificial intelligence, and deep learning. And interestingly, they have faster processing times compared to traditional compositional expressions for speakers of the language. Okay, so why should they be a problem for natural language processing, apart from all of these issues that I just told you about? Well, one big assumption that we do in NLP technology is that the meaning of an expression can be composed by the meaning of the individual words. So it's the principle of compositionality. So, for example, if you see a sentence like "the mouse is running from the brown cat," you would be correct in inferring that there is a mouse, there is a cat, which is brown, and there is a running event. And the meaning of this expression could be the combination of the meanings of the words. The problem is that with some of these expressions, you won't be able to take the meaning of the expression from the meaning of the words. So, for example, with Jane bought a grandfather clock, you have Jane as an entity, you have an event which is buying, and you have a clock. But what do you do with grandfather in terms of the meaning of the sentence? So, and just to clarify, grandfather clock is a type of clock. It's one of those tall, big clocks. So, what's the big deal? Is that the meaning of a multi-word expression may not be inferable from the meanings of the individual words. But the problem is that when we see a sequence of words, we never know if this sequence of words can be interpreted from its individual meanings or if it can't. So, for example, brick wall can be interpreted as a wall made of bricks. On the other hand, a cheese knife is not a knife that is made of cheese, but a knife for cutting cheese. So there is a different implicit relation. And in another expression, loan shark, you don't have a shark that is for loan, but you have a person who lends money at very high interest rates. So a little bit of a metaphorical shark, if you will. So the problem is that we have this high continuum of compositionality from expressions like access road, which is a road for accessing a place, to a grandfather clock, a type of clock, and cloud nine, which means to be in bliss or happiness. And it has nothing to do with either cloud or nine. So for NLP, it's really important to decide if a given combination of words forms a multi-word expression or not, or just a standard combination of words, like small boy. It's also important to decide how syntactically flexible the combination is, so that you don't generate things that are sound unnatural to native speakers. So if you want to use kick the bucket for dying, you probably don't want to generate the bucket that has been kicked, because then it would lose the idiomatic meaning. And also, you need to determine how idiomatic the expression is. So you have things like rocket science, which means not to be too difficult, versus olive oil, which has some relation with the words. And then you can decide if the expression can be processed by compositional methods or not. So, luckily, in this decision, we can use information from collocational properties, or how recurrent a given word combination is, from their contextual preferences, or about how dissimilar a multi-word is from the word components, and about canonical preferences. So, how fixed, how many variants a given expression can have. And also, we can use information about multilingual preferences, so asymmetries between different languages. So, in one language, a multi-word expression can be a multi-word expression, and it can be translated sometimes as a single word in another language. So, I'm going to tell you a little bit about some of the work that I've been doing with contextual preferences. So, one of the standard methods for capturing semantic properties of words in natural language processing is through word embeddings, or vector space models. And the idea behind these models is that you shall know a word by the company it keeps. That is, you use the traditional usages of the word to try to infer the semantics. And there are some traditional models like Lean from 98 and more recent models like Glove, Word2Vec, Elmo, and BERT. And the idea is that words are positioned in a multidimensional semantic space where the coordinates are given by the vector representation for the word. And proximity in this space indicates semantic relatedness. So the closer to our two words are in this space, the more similar semantically we assume they are. So the word embeddings give us an attractive framework for representing semantics because we can use algebra to model complex interactions between words. So for example, for multi-word expressions, one of the standard models that has been used is the additive models, where you sum the vectors of the individual components to derive the meaning of the compound or the multi-word expression. And you can also add weights to the different words of a multi-word expression according to their importance to the meaning. So, for example, for a partly compositional expression like flea market, which means just a market or a fair, the most of the meaning comes from market. So you can give it more weight than flea. And similarity and relatedness can be used to compare the words, the multi-words and their components. So what we usually assume is the following, that the cosine similarity between the representation for the multi-word and the sum of the representations of the individual components is going to give us an indication of how idiomatic the expression is. So for example, in here, in the inlay, you can see the vectors for ivory tower as a single unit, and the vector for ivory and tower that we can combine by a sum in this case, and use cosine to compare the distance between ivory tower and the combination of the vectors of ivory and tower. And the assumption is that if they are close together in semantic space, it's because their meanings are related or they are compositional. And if they are further away, it means that they are idiomatic. So the more distant, the more idiomatic. So however, how good are these models in representing idiomaticity? So a few questions that you can ask about these models is to what extent the meaning of different degrees of multi-word expression compositionality can be computed using this simple model, and whether the accuracy in predicting idiomaticity is related to characteristics of the word embeddings, or the particular languages involved, or the corpus size. So there are various questions that we can ask about how good these models are. And I'm going to just tell you a little bit about some work that we did with static word embeddings to determine to what extent we could really use them to determine the idiomaticity of an expression. And we did over 9,000 analyses and built almost 700 different models for compound nouns. And they are described in this paper here. They are joint work with Carlos Hamish, Silvio Cordeiro, and Marco Idiart. So we used various different models to compare how good each of them were, from standard positive pointwise mutual information models to Glove, Word2Vec, and LXVEC, which is a model that we devised in joint work with LXAI and Mark Widiart. And it outperforms Glove and Word2Vec in various similarity tasks. It's freely available. And to construct the models, we used comparable corpora in 3 different languages to see the influence of the language. So we used UK WOC for English, French WOC for French, and BR WOC for Brazilian Portuguese. And all of them have around 2 billion words. So the French is slightly smaller and the Portuguese is slightly bigger. And to determine if any processing was beneficial for these models, we also built 4 different versions of each of the of the corpus. So one of them is the corpus as it is with no pre-processing. Then in one of them we removed stop words, just use content words, and the other one we also lemmatized these content words. And in the final version, we also added part of speech tag information to differentiate, for example, verbs and nouns in English. And we also compare different parameters of these models, like the dimension size, the window size, the size of the corpora. So all of these analyses are detailed in this corpus. So to evaluate how good these models were, we collected also human judgments about idiomaticity of these compound nouns. So we have 208 compounds in English, two-word compounds formed by either two nouns or adjective and noun, like olive oil. And this data set for English extends the original data set collected by Reddy et al. With 90 compounds. And we have 180 compounds for French and 180 for Portuguese with similar constructions, a noun followed by an adjective. And all of the three sets are balanced for compositionality. So a third of the compounds are idiomatic, a third are partly compositional, and a third are compositional. And all of them are, again, freely available. So we ask the annotators in these tasks to judge the literality of the compound because they are non-expert annotators. So we ask them to say, for example, for a compound like climate change, if climate change is truly or literally a change in climate. And we also collected these judgments for the individual words of the compound. So we also asked if a climate change is truly, literally related to a change, and if it's truly or literally related to climate. And the participants were linguists, computer science students, and mechanical Turk workers. For Portuguese, as we had our expert annotators, we calculated the agreement among the annotators. And for the whole compound, we found a 0.42 alpha agreement. And to give you an idea of the difficulty of the task, we asked the same expert linguist annotator to re-annotate the compounds 1 month later. And he only had 0.59 alpha score with himself, which corresponds to a Spearman rho coefficient of 0.77. So it's a really hard task, and we can see this as the qualitative upper bound for compositionality that we could expect our computational models to reach. So to the results, using this family of static embeddings, what we found was that they actually did quite a good job in identifying idiomatic combinations, agreeing with the human judges. So for English, for the original ready data set with 90 compounds, we got 0.82 Spearman correlation, just with the models as they were without doing any fine tuning or anything. For the extended dataset containing 280 compounds, we got 0.73. But for French and Portuguese, the correlation was slightly lower, 0.7 for French and 0.6 for Portuguese. And the best models in the two languages were Word2Vec and pointwise mutual information. So now if we look at the type of preprocessing, so if just using the corpus as it is without any preprocessing gets as good results as lemmatizing and giving it part of speech information, we found that for English it doesn't make any difference. And the best results were actually obtained with the surface form of the corpus. But for French and for Portuguese, which are morphologically richer languages, then doing preprocessing actually gave quite a big boost. And the best results we obtained with lemmatizing and adding part of speech information didn't make much of a difference. And what about dimensions? So for the best models for all of the three languages, we found that using more dimensions gave us better performance than using lower dimensions. Okay, but can it have to do with the size of the corpus? because each of the languages had slightly different corpus sizes, and some of the languages are morphologically richer than the others. So this may also cause additional sparsity. But we noticed that if we divided the corpus into 10 different portions, what we found was that if we incrementally added these portions, the performance of the models stabilized after 1 billion words for all of the three languages. So if we gave more data, it didn't make much of a difference. And all the corpora were more or less around 2 billion words. Okay, so an additional work that I'm involved in is to try to determine now if in context the models can say if an expression is being used with its literal or its idiomatic meaning. So if you use see stars, are you referring to seeing stars in the astrophysical term of the word, that you see astronomic bodies, or if you are talking about pain and you are seeing stars, or if you are seeing stars like movie stars. So using contextualized word embeddings like bird and context to vec, we actually got much better results than just using static embeddings. But the interesting thing was that if even if we trained with a smaller corpus, a model like context to vec, as long as we treated compounds as a single word, we got much better performance than the standard models treating words individually. And the more recent work that I'm involved in is to collecting more annotations for the compound noun that I was telling you about, but in a per sentence basis. So we are asking judges to annotate if in a given sentence a given compound is being used compositionally or more idiomatically. Okay, so for conclusions, I just described to you a large-scale multilingual analysis of the performance of word embeddings for detecting idiomaticity in language, and specifically in compound nouns. And the investigation looked into English, French, and Portuguese compounds, and it involved almost 9,000 evaluations using different families of models. And what we found was that they actually do a really good job in capturing idiomaticity. And the results of this work were the data sets containing annotations by humans, which are freely available. And we also generated an additional data set for Portuguese, which has lexical substitutions that have been proposed by the annotators for each of the compound nouns in our data sets. So this resource is also freely available. So as future work, we are now want to investigate how we can fine tune and retrain really large models like GPT-3 and the bird family to to capture better idiomatic information. And this is especially crucial because they are really data intensive models, and you don't have sometimes annotated data in the scale that you need for this model. So we need to see how we can teach them about idiomaticity in general in an efficient way. And finally, we want to use these models for downstream tasks like machine translation to see if we can improve the results by having better models that are idiomatically aware. Okay, so that's it. I would like to thank you all again for inviting me here. So LatinX at NeurIPS, you rock. And I'll be delighted to answer some questions and for people to contact me after the event. Thank you.
Hello again. So we are here with Aline Villavicencio. We are here in the Q&A session. So please, people from the audience, please ask your questions. So meanwhile, I have a question myself. So in your talk, you assume that the kind of the easier language to process is a little bit English. Can you let us know why? Do you think, for example, Portuguese is harder to actually do this annotation or this idiomatic part?
Thank you. That's a very interesting question. And I think from the point of view of communication, all languages are equally hard or difficult. But the thing with Portuguese, French, Spanish is that we have a lot more morphological inflection. So if you have a text, you are going to have less evidence for each word in the text, just because we have so many plurals, we have gender, we have 60 something forms of verbs, which is very different from English. So that just means that we have less evidence for languages like French and Portuguese.
Okay, meanwhile, the audience is warming up. So, why do you think what is the challenges that you had when you were kind of like you annotate the different idioms, but you said that there were some kind of issues. Well, no issues, but the performance is very diverse. What are some aspects that this diversity, where this diversity comes into play at the time of annotation? It's a very hard problem itself, and even just automatic annotation is hard.
It is. And I actually had a very technical talk, and I was in two minds whether to talk more about the experience. But I thought this is a subject that deals with our languages. And so in terms of annotation, everybody is so creative in how they process languages. So for example, some people are very conservative and they consider that everything is very literal. Some other people really think that everything is more abstract, more metaphorical, very literary language. So even the same person judging the same sentence is going to have different views from one day to the next. And it's just because language is so creative. And the interesting thing about these idiomatic expressions is that they occur in every language and they are going to occur in different ways. So for example, the same idiom that we have in English, we are going to have the same concept in other languages, but in slightly different ways. And it's really fun to actually see that.
So, another question is like this part of like this context to back. You in your talk you show that is better performance. What obviously the context will take a lot of part on detecting if a language is an idiom or is a compose or is just a bag of words. But how would you apply this to actually search where you don't have any context actually available? How will work in this aspect?
That's a really good question. And that's one of the research topics that we are investigating. So if you just receive a sentence and you don't know if you have an idiomatic expression there or not, part of the research that I'm looking at is how to say if you have an idiom there, because if you do, you may get really inconvenient side effects if you are translating or if you are simplifying. So you may pass the wrong information. So as humans, when you are, let's say, learning a second language, you hear these expressions and you notice that there is something funny going on because the words don't make sense in that particular context. So that's how we detect that there is something that doesn't make much sense. And now what we want to do is tell models that they also, if something doesn't make sense, that they should be careful before processing the language.
So, but in that sense, this context, well, you show that it's a high improvement when you add context. But how the complexity of the resulting models look like?
That's a very good question. And one of the problems is that these really big models like GPT-3, BERT, and all the transformer-based models, they have billions of parameters, and they need loads and loads of data for you to train them from scratch. And of course, access to a lot of machines. So for many languages, we just don't have that. So one of the issues is actually how to make models that can learn from smaller amounts of data and can learn really fast as we do as humans. So this is another topic, but I think for the moment, these models are what we have, and they do well in a sense.
Okay. And well, one of the questions that I have is like, when you try to do this kind of adding multiple dimensions, for example, from the embeddings, is there a possibility to do a little bit like kind of like future engineering in terms of the dimension, not just figuring out all the dimensions will work better, but figure out what could be which part of the dimension, why so certain parts of the dimension will work better, or if there is a correlation itself inside the dimensions.
That's a really good question. So in old-fashioned embedding models, the dimensions were words that occurred in this text. So you could see, for example, dimension 1 would be the verb to eat, dimension 2 would be the verb to bring. And then you could interpret what was happening and what were the important dimensions there for a given expression. And in fact, we saw that if we selected the most salient dimensions for each of the words, that's when we got the best results. So that's one of the models that we actually show there. But with neural models, you know that there is something being expressed in a dimension, but you don't know exactly what. So what some people have been doing is actually to try to see for a given word, what are the meaningful dimensions and what they can relate to, what could be the interpretation. So there is a lot of work now on natural language processing on the interpretability of models, and it's a rich work. So if you are out of ideas about what to do, interpretability of models, and second, idiomaticity of language. So, just come and talk to me.
So, well, that is a very actually interesting area of research. But I would like to kind of ask, this part of interpretability has been kind of is one of the hot topics right now. But what about bias at the time that we actually train the models to follow a specific idiomatic that may not be kind of politically correct or even just is totally incorrect, I will say.
That's again a really good point. So one of the things that we are doing is actually we can see indirectly the bias of the language in terms of how an expression is interpreted. So we can say, for example, okay, an expression like piece of cake is closer to cake than it is to something easy. So we can think that, okay, maybe in the training data, there were more instances of baked goods than of a piece of cake as easy. And that's a silly example. But what you were saying is that a lot of our prejudices or, biased content is present in this corpora. And at the moment, we are trying to use external means to try to detect when this is happening. But we don't just know when something is happening. If we think of that bias, so for example, for gender, we know, okay, so we have a few tricks to compare the vectors with the vectors for biased language. And if we know that there is racial bias, we can measure that as well. But how many other biases are there that we can't detect? So that's really, really important. And because if we know that they are there, we can detect them and we can try to remove them from there. Because the models are only going to be as good as the data we train them on.
That actually lead us to a very good question. How do we select the data? Sometimes we don't have actually able to select even, but how do we try to make sure that we select the correct data without leaving us without any data? Is there kind of, what are your points about that?
So the other part of the research that I do is actually looking at cognitive computational models. So we look at data from children and parents, and we try to see if we can build models that can learn from children's data, for example. And one of the things that we could do, for example, with these models is try to teach them from small data, small and maybe more ideal data. And once we know that they can do some basic understanding, we can let them go to a bit more challenging data and hope that they have enough of a basis that they are going to pick up the good things, but not the bad things. But that's an ideal, that's a dream case scenario. So in more realistic terms, unfortunately, these models are trained with billions and billions and billions and billions of texts. And there is no way that we can control everything that is in there. So we need research actually on how to sanitize and clean the data and remove at least the most obvious biases. Because if we can remove those, at least the monsters we deal with, and then we need to sift the data to see if we can find other things that are equally bad, but maybe more difficult to detect. So let's face the big monsters first, and then let's target the other things.
And I think a little bit the last question could be like, what is the future in that sense? What do you? Actually, we have a question from the audience. It's like, what are the challenges in terms of knowledge representation for idiomatic expression? Is there work on building something like idiomatic knowledge graph, similar to a taxonomy? What do you think?
That's a really, really good point. So there are some resources like WordNet, which is one very traditional psycholinguistic resource that we use, but it has very limited coverage, and it's not available for all languages. And for idiomatic expressions, we are so creative that we create them all the time. So at the moment, a lot of the important inferences that we can do are on good knowledge sources. So we are building slowly, and there is a lot of work to be done. So if you actually think that this is something that people would be interested in doing, please come and talk to me, because we really need that. We have small data knowledge sources, but we need many more. And for example, being a Latin American, there are so many languages all throughout Latin America for which we have no resources. So let's do something about that.
And I think the last question from the audience is like, when training big models like BERT, tasks like paraphrasing, they are not getting the idiomatic expression. What do you think can be a solution for that?
So that's, well, guys, you're really, really, really good questions coming up today. So that's another of the areas that I'm recently doing research. So some of the work that we are doing is actually trying to come up with loss functions that we can use to train BERT or to fine-tune BERT, to teach it, for example, or similar models, how to interpret these expressions. The problem is that we need lots of data to do that. So for the moment, we are devising probing tasks to assess just how bad these models are and what we can do to make them better. So again, if you want to work with this, come and talk to me. So I'm based in Sheffield and in Brazil, and I'm looking for collaborators. And I would love to have as many collaborations with Latin America as possible, either via Brazil or via Sheffield. So let's work together.
That's really nice. And really thank you for answering all the questions from the audience. I think that there was people from the audience liked it a lot, your talk. Well, personally, I liked it a lot. So, and thank you for your time.
Thank you so much for inviting me. It's been really fun participating during the day. So thank you.